So I wanted to do an example or two from the first unit to highlight some of the topics that are a little more challenging than the others. And we're kind of in the second half of the first unit now. And toward the end of the first unit, inequalities are one of the topics that I want to make sure that we get some screen time for. So here's an example from objective number 56, which is solving a linear inequality. This particular linear inequality has variables on both sides of the inequality, and it also has fractions, two of the features that make this the perfect kind of example to look at the techniques that you're likely to use, not just in this context, but in some other contexts as well. So let's take a look at what it's going to take to solve this particular linear inequality for W. So anytime the word solve appears in a problem, the objective is to get the variable by itself. So in this example, the variable is W. We need to get W all alone by itself on one side of the equation. So here's an idea. First thing I want to do is I want to ditch the fractions. Anytime you can ditch the fractions, it's a good idea, right? Because even I, as a mathematician, would prefer to do arithmetic with whole numbers rather than fractions if I can get away with it. So we're just going to do one step at the beginning of the problem to totally nuke the fractions, called clearing denominators. And then once that's done, then we'll be able to unwrap the variable. In other words, get all the arithmetic that surrounds W out from around the W to get the W by itself. At that point, we'll have a solution in the form of an inequality. Then we'll be able to write that solution using a number line and using an interval notation. So one step at a time. First, let's talk about clearing denominators, nuking the fractions so that we can work with just whole numbers in the end. Well, the only denominator, the only fraction in this equation is that -3/2 out in the front. So if we're going to clear that away, we need to clear away that denominator of 2. The idea behind clearing denominators is to multiply by a whole number that will clear all the denominators of all the fractions away. And since 2 is the only denominator here, let's just multiply everything by 2. If I multiply everything by 2, distributing the multiplication over the addition and subtraction, then what's going to happen is that -3/2 times 2 is going to become -3 in the beginning, and that was the only fraction that we had. And after our denominators have been cleared, again, distributing that multiplication, we get the new inequality, -3W minus 4 is less than -18W plus 12. So our clearing denominator step is all finished. Now we just need to get that W by itself. And getting W by itself requires a two-step process. The first step of the process is to get all the W's onto one side of the inequality. We can't do anything until we get the W's in one place. And anytime you need to move variables from one side of an equation or an inequality to the other, subtraction is the way to do it, subtraction or addition. It's very common that students will try to divide or something in a case like this, and that just isn't going to do it because the variable here is in a term, an additive term. So to move it from one side to the other, we really do need to subtract. So I'm going to focus in on that -18W on the right-hand side. Subtract that term. Subtract -18W from the right side from the left side. That's going to have the effect of getting rid of the W term on the right-hand side of the equation and then combining with the like term -3W on the left-hand side of the inequality. Keeping in mind that subtracting a -18W is the same as adding a positive 18W. What we're going to get on the right-hand side is just plain 12. We don't have any more variables on the right-hand side, which was the point. Now on the left-hand side, we'll combine those like terms. -3W plus 18W will give me 15W, and we still have the -4. So now our W only lives on one side of the inequality, which means now we can unwrap it using the reverse order of operations that I call SADMEP. Let's deal with all the addition and subtraction first. If we can do any addition or subtraction to get the W to be more unwrapped, let's do that first. Then we'll do any division or multiplication we need to do to get the W unwrapped. And then if there are any exponentials or there are any parentheses, that we can worry about those at the end. So according to SADMEP, the first thing I want to do here is see if there's any addition or subtraction that can make my life easier. And there is. If I add 4 to both sides of this inequality, I'll get 15W on the left and 12 plus 4, 16 on the right. Now there's no more addition or subtraction I can do to make this simpler. So I'll go for division or multiplication. In this case, dividing will turn 15W back into just plain W, which is what we want, by dividing by 15. If I do that on both sides of my inequality, I'll get W by itself to be less than 16 over 15. So now the W has been completely unwrapped, and this is more or less a solution to this inequality. Now, the question didn't ask us to do this, but I might on an exam, or a different question might ask you to do this. Let's visualize this inequality, not just as an inequality as it's written here, but also let's depict it on the number line, and let's write it in interval notation. So first of all, for the number line, I'm just going to draw out a blank number line, label maybe a few of the integers here in the middle. 16 over 15 happens to be just a little bit more than 1, so I'm going to label that right there on the number line. And because our inequality has a solution which says that we want the w's that are less than 16 over 15, that means I want that piece of the number line which lies to the left of 16 over 15. So I'm going to shade that, starting from 16/15 and going all the way to the left, quote unquote. In this case, all the way down to -infinity, if you like. Also, because w is strictly less than 16 over 15 and is not equal to, in other words, because we have the strict form of the inequality sitting right here, and it's not less than or equal to, it's just less than, I'm going to put an open circle right there at 16 over 15 to denote that we're not including that number specifically, but we're including every number which is less than that. So there's a depiction on the number line of what the solution looks like. To write interval notation for it, we need to know 4 things. First of all, what are the lower limit and the upper limit of this interval? Since this interval goes all the way to the left, it doesn't have a lower bound, we're going to say that the lower limit is -infinity. That's just the way that we communicate that there is no lower extent to the interval which solves this inequality. On the other hand, the upper limit is pretty clear from where we sketched on the number line. 16 over 15 is the upper limit, the upper bound, if you like, of the interval which solves this inequality. So those are the first 2 pieces of information we need for our interval notation. The second 2 pieces are to communicate whether or not these limits are actually a part of the solution or not. In the case of -infinity, certainly infinities are never going to be a part of our solution. 16 over 15, on the other hand, as we've said, should not be included in our solution because the inequality itself is a less than and not an equal to inequality. In other words, if I try to put 16 over 15 in here for w, I'm going to get something which is false. 16/15 is less than 16/15. So I don't want to include 16 over 15 in my solution. In other words, neither this lower limit, because it's infinity, and infinity is never included, nor this upper limit, which is 16 over 15, which is not included because of the strictness of the inequality, should be a part of our final answer. We'll convey that in interval notation by writing the lower and upper limit with a comma in between, and using a round parenthesis for each limit that we don't include. -infinity, which always gets a round parenthesis because we never include it, and in this example, 16/15 gets a round parenthesis also because we don't include it. So this is a complete solution for how to solve a linear inequality, which in this example has variables on both sides of the inequality and also has fractions. We started by clearing denominators. Always a good decision when you start a problem that has fractions, especially if there are multiple fractions. Here there was just a single one. And so it just took multiplying by that fraction's denominator, too, to clear out all the fractions and give us nice whole numbers to work with. Then we had to contend with the fact that there were variables on both sides. So we subtracted the term from the right-hand side, -18w, that had the variable, over to the left-hand side. In other words, we added 18w, so that now there was just a single term that had a w in it, and it was on the left side of our inequality. Then we just had to unwrap that variable using the reverse order of operations, first adding 4 to both sides, and then dividing by 15 on both sides. That gives us a solution to this inequality in inequality form. W is less than 16 over 15. Finally, we visualize this solution on a number line by drawing out the bound, 16 over 15, slightly bigger than 1, and shading the entire portion of the number line, which is to the left of that upper bound. We can then turn that into interval notation by identifying the lower and the upper limits of our solution, and then deciding for each of those limits whether or not that limit should be a part of the answer or not. In this example, the answer was not on both cases, and so the interval that we answer with has round parentheses on both sides.